guys, this is Miss Mariana, and in this video we're going to study powers and radicals. First, we're going to go through powers, and then in a second video, we'll go through radicals. This video is designed mainly for an ESO3 and an ESO4 level, but if you're in ESO2 and you're eager to learn all these properties with a little bit of a higher level, this video is also for you. So here we go. Let's begin with the basic vocabulary for powers. So here we have an apple and we have an m in very specific positions. The apple is the base and m is the exponent. As you can see right here, we have the exponent here and we have the base immediately below the exponent. So having this written, we read it as apple to the power of m. And this is extremely important to know because when we learn to read the mathematical expressions as we have to, our brain will understand them better, okay? So we have apple to the power of m, where apple represents any kind of expression that will be modified by the number that m is. Remember that the exponent tells us how many times we have to multiply the base by itself, okay? So this is the first part. Then we have this second expression right here, where we have apple to the power of negative m. Guys, a lot of attention here, please. When we have a negative exponent, the only objective of that symbol next to the exponent, the negative symbol, is to change the base from position. So if we have it in the numerator, it will go immediately to the denominator and vice versa, okay? So once we make that change, the minus disappears. See that here we have apple to the power of minus m, and here, now that it is in the opposite position, the m is positive because we already operated the negative, okay? Now with this done, remember, this is information that has been given to you since basically first of ESO, maybe even before. If we have a negative base and an even exponent, we will get a positive result. And if we have a negative base and an odd exponent, then we'll get a negative result. Examples for this are not going to be given in this video because remember that the level is mainly for ESO3 and ESO4, and this is information that you already know. This is just a brief reminder. Now, let's go through the properties. The properties are several, exactly 6 as we have here, and we will explain them, okay? So let's go one by one. Here we go. So we have the product of powers. Remember that all the properties that we're going to see here, well, the first 3 are applied to expressions that have the same base, okay? So we have apple to the power of m and apple to the power of n. This is a product of powers where the powers have the same base. So if the powers are multiplying, then we have to add the exponents and it becomes only one little expression right here. We're going to do examples afterwards. Then the quotient of powers, here we are missing an n. We have apple to the power of m divided by apple to the power of n. So this is going to become one expression where the base is going to be placed on the numerator and then the exponents are going to be subtracted. We're going to keep the first one, the one in the numerator, with its sign, which is if it's positive, we keep it positive. If it's negative, we keep it negative. And then we're going to subtract the exponent that is in the denominator. And this is always done this way, okay? If we see the possibility, we can simplify before applying the property. But the idea is to understand how to apply the property too, okay? Then we have property number 3, power of a power. In this case, the only thing that we have to do is see that we only have one power with its exponent and then its power. It has another power next to it. So it's apple to the power of m to the power of n. So these two are going to be multiplied, okay? Then let's continue right here. In these two that we're going to see here, we have different bases. We have an apple and a lemon, okay? Or whatever you want it to be. It can be a kiwi as well if you want. Then we have apple times lemon, and both are going to be to the power of m. So what does this mean? That they share the same exponent. So it's going to become apple to the power of m and lemon to the power of m. Remember that the properties can be used in either way, okay? We can use them from left to right or from right to left. It's going to depend on what we get in the exercises. Then, the power of a quotient is exactly analog to the power of a product. But in this case, they are dividing. So we have apple divided by lemon, both in parentheses to the power of m. So they are going to be apple to the power of m and lemon to the power of m as well. Here we have to change it. Let's do this brief modification right here. And that's it. Okay, so the last one is a very, very important property where we have exponent 0. Whenever we have any kind of base to the power of 0, it's going to be 1, okay? And this is something that we have to believe at first, but in this video, I am going to explain how it works, okay? And it works as a consequence of other properties. So let's explain it right here. Let me choose the colors to explain it. So imagine we have, for example, 5 power 3 divided by 5 power 3. So in this case, we have the same divided by the same. So whenever we have the same number in the numerator and the denominator, the result is gonna be 1, right? So let's take that information all the way here. And we already know that the same divided by the same is 1. We already know this. 2 divided by 2 is 1, 3 divided by 3 is 1, 5 power 3 divided by 5 to the power of 3 is 1. So this becomes 1 because we already know this from a very long time ago, but applying properties, what do we get? In this case, we would have to apply the quotient of powers, where we have apple to the power of m divided by apple to the power of n, and it becomes 1 apple and the subtraction of the exponents. So here we're going to do the same. So this is going to be 5 to the power of 3 minus 3. So I am going to do this a little bit smaller because I'm going to need this space. So 3 minus 3. So this exponent is going to become 0. And as you can see here, it all equals 1. Okay? So this is how this property works. Okay? So with this information given and this very quick review that we just did, we're going to go to the exercises. We're going to do the following 4, as we have right here. Okay, so let's begin with the exercises. Here we go. Sec. All right. So I'm going to rewrite the exercise. And first, we're going to observe to see what we have to do and what properties we need to apply. So see here that all these 3 powers are multiplying, okay? So in this case, we would have to apply the first property, product of powers. In this case, we have 2, but it's exactly analog if we have 3, 4, or 1,000 powers with the same base that are multiplying. So if we have the same base, the only thing that we have to do is that we have to rewrite the base, and then we have to add the exponents. So look at this here. We have 5 plus, in here we have a minus that could be confusing, but it's not. The only thing that we're going to do here, we're going to put it in a parenthesis. And we're going to close it right here. And then we're going to add the last one, okay? So see here that the only thing we did was adding this, this, and this. So it became this. So with this done, we only keep the base as it is. And now we just have to operate the very easy addition that we have right here highlighted in yellow. So we have 5. Here we have to multiply the signs, not the numbers, the signs. And then we have a minus 2 plus 4. So we get 3 to the power of 5 minus 2 is 3 plus 4 is 7. So this is it for this exercise. So the only important thing here, let's say the tricky part was exactly this one, where we had this plus and this minus. You have to be very aware of the operation of the plus and the minus, okay? So we would get, in this case, a -2, okay? Let's continue with the next one. Let's go for B. Let's rewrite it right here. So see here, guys, that we have an operation where all the bases are the same. Our apple is a -2, but we have different operations. We have a multiplication and a division. So we have to do this exercise in 2 parts. What parts? The ones that are indicated by the operations, the multiplication and the division, okay, the quotient. So we're going to associate only with colors to tell our eyes how we're going to start this exercise. So in red, I will put this, and this is the first part I will do. And then this result is going to be operated with the division as a second step, okay? So let's do the first step first, naturally. So we have the red part, it's this -2 right here, and we have that -2 to the power of -6 times -2 to the power of 4, as they are multiplying and they are the same base, the only thing that we have to do is add the exponents. So we're going to keep the parentheses because this is our whole base. When we have negative bases, guys, always use parentheses. Always, 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 because there is a very common mistake when the negative is part of the base and when it's not. Okay? So we have -6 or -6 plus 4. And we're going to keep the second step of the division right here. Okay? We just rewrite it because we haven't done anything with it yet. So let's put it right here and let's remember that this is this. All right. Well, we're gonna get -2. -6 plus 4 would be -2 or -2 divided by -2 to the power of 7. So now we have this second step where we're doing the division, okay? So as this is a quotient, then we have to subtract the exponents, the one in the numerator minus the one in the denominator, okay? I am going to do this right here, where we keep the base in the numerator, so we write it down. See that I am not doing anything with the fact that the base is negative. The only thing that I am doing is keeping it in a parenthesis. It's the only thing. It doesn't have to confuse you. It's not going to change anything because in this case, the base is always the same, okay? It's our apple. Then we have the quotient. So we get -2 minus 7. So we have -2 minus plus 7. So we're going to keep it as 7. Okay? So in this case, we have -2 to the power of -9. In theory, this exercise is done, but we have some things that we could still operate with. So in this case, I am going to rewrite this here. See that we have, right here, a negative exponent. That means that we have to do the inverse of the base, okay? So we're going to do that in about a second. I'm changing colors. So here we go. So once we detect that negative in the exponent, we operate it. So what do we put in the numerator if we don't have anything, as we would say? We do have something, which is a 1. Okay? We have it right here. Very invisible, but it's right there. Okay? So we put this 1 right here. And we are operating the negative of the exponent. So we keep the negative of the base. And now we have this. And now we have to remember what we studied at the very beginning of the video, which is the behavior of the base depending on the nature of the exponent. So here we have, in this exercise, we have a negative base, which is -2, and we have an odd exponent, which is 9. So the final result will be negative. So let's go right here. And we are going to do this. Like this. And if we want to put it very, very pretty, then we put the minus parallelly to the line of the fraction, 1 divided by 2. And here we put power, or even, if you wanted to, we could say minus or negative this to the power of 9, because 1 power 9 is 9 as well. Okay? So this is the second exercise. Remember that the instruction, as you might have read, is to simplify each expression and give the answer as a single power. So that's what we're doing in every exercise so far. Let's go to exercise C, where we're going to do more things. We will have to take more elements into consideration and more steps in the middle of the exercise. So I am going to rewrite it. Let's go here. Divided by 5. Divided by 25. Power 2 to the power of 2. And this is to the power of minus negative. All right. So here we have this exercise. So see that we have a fraction. We have two fractions where the the base, like we have a fraction as a base, where both seem different, but they are not. Okay? Because we have 4 divided by 5, and then we have 4 divided by 25. But if we factor 25, we'll have 5 to the power of 2. So we can convert this fraction or this power into the same base as the first one. So this is the first thing we have to do. The first thing we have to do is observe if all the bases of all the powers are the same to be able to apply the properties. If they are all the same as exercise A and B, sorry, then we'll just apply them directly. But in this case, we have a slight difference in the second power. So I am going to call your attention right here. I'm going to do it slightly. Here we are. Okay, so I am going to work this one on the side for 25 is going to become 5 to the power of 2. Okay? We could also factor 4, but we don't need it right now. We're going to do that at the end to express it as a single power. Then I am going to rewrite this part right here, or divided by 5, or divided by 5 power 2 to the power of 2. This is to the power of minus 1. You might wonder why we are not operating this one right here. Don't do it because it's not convenient, okay? Remember that we need our powers with the same base. So if we apply the negative power here at the beginning, we're going to have the inverse. We would have 5 over 4, and we don't need that right now. We need them to be exactly the same so we can apply properties. And that's the treatment we're doing now to the expression, okay? So let's see here. All right. Let's continue here. So we have 4 to the power, 4 divided by 5 to the power of minus 2 times 4 divided by 5 power 2 to the power of 2. And all this to the power of minus 1. See that what we're doing here is that we're treating the expression from inside out, okay? And this is the way we always operate with this kind of exercises with powers, okay? So what do we have here? We have, from the property seen at the beginning of the video, we have the quotient of powers, which is this one right here. Okay, so we're going to apply that property number 2, where we have, oh wait, no, it's not quotient of powers, but I observed wrongly because we have two different bases right here. We have a 4 and a 5. So in this case, we have the power of a quotient. We have a quotient of two different numbers and a common exponent. So we're going to take each of the elements of the fraction to the power of m, okay? In this case, to the power of 2, which is right here. So let's do that right now. 4 divided by 5. To the power of 2. 5 to the power of 2. And again to the power of 2. See right here that we have another property for the 5, where we have to multiply these two. To the power of 2, and finally 5 to the power of 4. See that it took a little too long regarding how easy this operation is, but I chose to do it this way so you understand each step of the way, and then in the following exercises, we're going to do it directly, okay? So if we have to express it as a single power, now we have to apply again the same property as we did before here. So we have 4 to the power of minus 2 divided by 4 to the power of minus 2, or negative 2, sorry. Then we have 4 power to the power of 2 and 5 power to the power. This is the power of minus negative 1. So here we have, see that in this expression, let's observe, we have 4 times 4, and we have 5 times 5. In the denominator, we have the 5s multiplying, and in the numerator, we have the 4s multiplying. So we're going to write them all on the same line or level. So we have 4 to the power of -2, 4 to the power of 2, divided by 5 to the power of -2, sorry, times this. And now we see that we have same base in the numerator and same base in the denominator. So we're going to apply the property on each level. So we have this, and then we have this right here. Okay. So as we have the same exponent, we only need to add, sorry, as we have the same base, we only need to add the exponents. And right here, same situation, same drill. So we have 4, -2 plus 2 equals 0. And then we have 5 power 2. So remember, guys, 4 to the power of 0 or anything to the power of 0 is 1. And then we get 5 power 2. So if we need to express this as a single power, it would be 1/5 to the power of 2. And I am forgetting something. I forgot that all this is to the power of -1. So I'm going to write it right here. I got excited because I thought that we were already finishing and I forgot that important exponent right there. See that I am going to keep it till the end. So now we're going to apply the last exponent given as the last step of the exercise. I am changing the colors. So here we go. We have that power. First, we have the power of a power, which would be the multiplication of these two. So this is -2. So now that we have a -2 as an exponent, what does this negative do? It changes the position of the base. And in this case, as the base is a fraction, then the numerator goes to the denominator, and then the denominator goes to the numerator. We have the inverse, okay? In just one word, the negative of the exponent gives us the inverse of the base, okay? So if we have 1/5, then we have 5. And this becomes 5 power 2. And this is the single power that we had to represent, okay? So this is for exercise C. And let's go for the very last one, which is an easy one. 12 to the power of -2 times 16, if I remember correctly. Yes. So see here, guys, that we have numbers that we need to factor before doing anything because they are both different. We cannot apply any kind of property if we don't have the same base for the powers. Okay, so let's remember that 12 is 3 times 4, where this would be 3 times 2 to the power of 2. And this is 12. So this guy right here becomes this, and all this to the power of -2. And then 16 It's just as having 4 power 2, which is the same as having, let's write it right here. And we know that 4 is 2 to the power of 2, which was already to the power of 2 before. So this becomes 2 power 4. This is a very easy and fast way to factor the numbers, okay, into their prime numbers, and you don't have to do the whole thing. So you do it a little bit quicker and you save time. Then we have this, and see here that we have different powers, but 2 of them are the same. This one and this one. So we are going to be able to apply properties there. Let's see if we're able to express it as a single power. Let's see. So we have, in this case, we have 2 different kinds of bases, an apple and a lemon, to the power of -2. So we're going to power each of the bases right there. So we have 3 to the power of -2 times 2 to the power of 2 to the power of -2. Remember to use parentheses when we have the power of a power or when we have negative bases for the powers, okay? Those are the 2 situations. Then we have 2 to the power of 4. Then we have 3 to the power of -2. Then we have 2 to the power of 2 times 2 is -4. And here we have 2 to the power of 4. So as you can see, guys, right here, this -4 plus this 4 becomes 0 for the exponent, which means that we get a 1. I am going to do it step by step here. We could add them, or we can get the inverse of this, which would be the same as 1 divided by 2 power 4 times 2 power 4, and then we can simplify if you prefer, okay? And then with this, we would get directly 3 to the power of -2. And as we have a negative exponent, we get the inverse of the base. So the inverse of the base is going to be 1/3. And we're going to keep the exponent. But the negative has been already operated, so we don't put it. Then, if we want to express it as a single power, 1 can be to the power of anything. It's going to remain as 1, and then we have 3, and this is going to be to the power of 2, because 1 to the power of 2 is 1, and 3 to the power of 2 gives us this one right here. So guys, this is everything for today. I really hope this was useful for you. And we're going to continue working. I am going to keep uploading exercises so you're able to practice, okay? If you have any questions, you can always comment, all right? Thank you very much for your attention, and I really hope this was useful for you. Bye-bye.